Hello interwebs, welcome to Let's Fix Computers. I've got a HP laptop here. This is a 15s-fq series. There's customer data on the bottom, so I have to cut between moving the laptop around. And it apparently does not power on and does not charge. So I'm assuming that means we've got no light on the charger. So let's just plug in a charger and see what it does. Yeah, that's a no from me. Okay. Let's open it up and take a look. Okay, right, we've got the back cover off of this thing. Let's do some stabbing. So I'm going to turn my multimeter to resistance mode. And the first thing I'm going to do, we're going to track the DC jack from the bottom left here up to the motherboard. Comes in under this ribbon, so let's just pop that up. And we're just going to check if there's a short circuit at the DC jack. So if we punch down a little here, we've got two red pins coming in, and they go to this big fat trace here. And there's two black pins that come in that go to a large pad here that is then going through to the other side of the board. Oh, and before I take any measurements here, I should disconnect the battery because that'll throw off our results. And we've got 1.2, 1.3 mega ohms, so that's huge. That's lots of resistance. If we're looking for anything above, we're looking for anything above 20k, and that is fine. Anything that is below 20k is suspicious, and if we actually found a short circuit, we'd be expecting to see like 0 ohms or less than 1 ohm. So this is completely fine. So if we follow this trace up from the positive pins, we've got a TVS diode, and that's there to protect from gross overvoltage or reverse voltage and things like that. So that's going across to ground. This guy is okay, otherwise we would have a short circuit here. Then we go into this MOSFET, and we come out here, and then we're going up into another MOSFET here. So these are the DC in MOSFETs, and this is effectively an electronic switch that allows the laptop to switch the incoming power on and off as it sees fit. So we're going through these two MOSFETs, and then we come out at this trace here. And then that trace, it's going up to the battery, and also it's coming down through this current sense resistor here. So this whole area, once we're past these two MOSFETs, we're on the main DC in rail. So let's just put a red probe onto that current sense resistor. It doesn't matter which side we pick. And we'll put the other probe just on a screw hole for a ground. And let's see what we get over there. Alright, that's still mega ohms. We've got like 10 mega ohms. It's drooping just as it settles, but the point is we still have lots and lots of resistance. Again, we're looking for 0 would be a problem. Okay, so we're still not seeing anything. Let's move a bit further up and take a couple of other stabs. I tell you what, I'm going to jump up to the money shot. Here's our CPU, and this area here, this is CPU V-core. So this is the power supplies going into the CPU. These guys are being supplied directly from the main power rail. So let's try taking a stab at those and see if we spot anything. So these two are going to be the main MOSFETs, and just on the outside of those, we've got some empty pads where you could put big capacitors. And one side of that is going to be the main power rail going into the MOSFET, and the other side is going to be ground, but we don't know which is which, so we're just going to try both. I'll put my black probe back on a screw hole. I'll put it down here just so you guys can see where I'm stabbing. So black probe is on a screw hole, and let's just try this pad here and see what we get. And once again, we're seeing very, very high resistance. Tens of mega ohms. So the other side, this is going to be ground. Alright, so there's actual ground. So that's to be expected. Alright, so we don't seem to have a short circuit here then. Alright, there's no short circuit on the main power rail. What about other power rails? So what I'll do now is we've got some secondary power rails on the motherboard. We've got some secondary power rails up here. These black squares, these inductors, these are going to be voltage regulators for secondary rails. The 1 volt rail, 3.3 volts, 5 volts, things like that. So basically, I'm looking for any of these big squares. So there's going to be a 3.3 volt, a 5 volt. There's probably a regulator around here that will be 1.2 volts for the RAM, which I think is going to be that one. Then there's another one over here, which may well be either our battery charger or our main rail supply, depending on what kind of main rail we've got. I haven't looked in detail to see what that is yet, but that doesn't matter quite yet because we haven't found anything. So I'm just going to stab all of these inductors and see if we find anything that looks suspicious. So let's start over here at the memory rail. Oh. Okay, well that guy is 0.3 ohms. Alright. Pretty suspicious. Let's check the other ones. That's 40 kilo ohms. That's good. Decent amount of resistance. Not 0. 162 ohms. I think that's going to be our 3.3 volt rail, and I think that guy sits fairly low. So 161 ohms, that's low, but I think that's normal. Could be wrong. And we'll check this guy over here just for posterity. Yeah, we got like hundreds of kilo ohms over here. No problem at all. Right, so this guy on 0, that's mega suspicious. This is probably going to be memory because it's near the memory, basically. That is as good a guess as any. I might be wrong, but I'm just going to try popping out the memory modules. The hell happened here? This looks like a motherboard that's been reworked or something at some point. Replaced, maybe. The memory modules are... this is DDR4 2666, and we've got 8 gigs worth in there. So with the memory modules removed, let's see what happens. I might be completely wrong about this being the memory power rail. It's just because it's nearby, and that is usually a reasonable indicator. That's still 0. Okay. At this point, let's dive under the microscope and look a bit closer at this area. And let's see if we can spot anything around there that's going to give us a help. Okay, so here's that inductor we were just looking at. Still not sure what this guy's for yet, but we'll look up some schematics in a minute and we'll see if we can find out what this is. But let's just do some more pot shots first. So we know we've got 0 ohms of resistance at this inductor. Now, this guy itself is not going to be the fault. The inductor is just a coil of wire from here to here. It doesn't have a path to ground. So the inductor or the coil, this itself cannot be the fault. Except for some very, very obscure instances, which we're not going to get into because it's not relevant. So what we're looking for is something connected to this that does have a path to ground. So let's think about this. We've got some capacitors right here. Capacitors, 9 times out of 10, are going to ground. This is probably a ground plane. So any of these capacitors may have failed, which would drag this connection down to ground. That's what we're looking for. So we've got some capacitors there. We're going over to this chip here. And on the other side of it, we've got another chip. There is a capacitor there. And that's about our lot. So let's do some probing around these other areas and just see how far out this short circuit seems to go. Or, well, this low resistance at least. So I'll put my black probe back on a screw hole. And let's just check again to make sure we're still seeing that short circuit. So on the back of the inductor, we're seeing fundamentally 0 ohms. So what about the other areas of this chip? So what about over here? What's that? That's 610 ohms. Okay. What about up here? Mega ohms, no problem. What about up here? I don't know what any of these pins are. I'm just looking for large pads. That's 0. However, also remember, this was high resistance and we've got a capacitor going across to here. So this is almost certainly going to be ground because it's a capacitor between an input power rail and a ground pad. So that's probably a ground connection. Okay, so there's nothing super suspicious up here. If we found that like everything going into this chip was shorted, we could make an assumption that this chip might be faulty and has shorted everything it's connected to, including this, down to ground. But that's not what we're seeing, so let's try the other side. So these capacitors, these are all going to show ground because we've got ground at the coil. So if we check here, yeah, there's our 0 ohms again. This is a power rail of some sort. So this is another pad where you could put a massive bypass capacitor. So this should be ground, I would expect. Yeah, so that's also ground. So let's come down to this chip here. So let's just try probing the other pads on this chip. So this big space here, this is coming in underneath the chip. And a connection on the bottom of the chip is nearly always going to be ground. And again, if we follow this up, there's a big pad here that goes to the other side of these capacitors. So this is going to be ground coming in. So that looks like it's going all the way through to the other side. So this is probably ground here. Which it is. Okay, so what about this pad here then? Right, that's showing 2.6 ohms, which is very low, but it's not our short circuit. All right, what about this guy over here? 2.4 kilo ohms. Okay, that's higher. All right. Then we're going down into just stuff and things. Could be things on the other side of the board. No idea what this is or where it goes. All right, so you know, I'm going to take a real close look at those capacitors and see if it's just that easy. That guy looks pretty good. Those both look okay. All right, I think I'm going to inject a little bit of power on that and see what happens. So let's go through our checklist before we do power injection. Why are we injecting power? Well, we've found a short circuit, but we don't know what component is actually shorted. Why do we think power injection is going to solve the problem? Well, we have less than 0 ohms of resistance, and if we put some power into there, whatever is shorted will conduct the power, get hot, and reveal itself to us. So it will show us which component is shorted. Cool, so far so good. Do we think the power might go somewhere else unexpected and damage something? Well, I don't think so, because we haven't found any outputs from this enclosed area that are also directly shorted. Granted, I haven't looked on the other side of the board, though. Okay, let's take the board out and check the other side of it. Even if it's one of those capacitors, we still need to take the board out if we're going to take that capacitor off anyway. Well, I mean, I guess you might do, but it's good practice to remove the board. So let's take the board out and we're going to check the other side just to make sure that there's nothing unexpected there. Yeah, I know it's a drag, but this is what good practice is. It's being responsible when you're working on stuff and making sure that you're taking all steps that you can to not make a mistake and damage something. And, you know, if you're super duper professional and you know exactly what you're doing, you might be able to skip a lot of this stuff because you're like, I know better than that. But if you're learning how to do this and you might miss things that professionals just take for granted, well, you do all of the steps to protect the device first. Right, there's almost nothing going on the back of this board. It's almost a single-sided load. Just a bunch of bypass capacitors mostly. So our inductor is there. There is mostly just a massive ground plane on this side of the board. So we're not seeing any other locations that this circuit is going that we did not anticipate. That's the important thing. And also we're not seeing any components on the back of this board that are exploded and probably causing an issue. So, okay, good. Well, in that case, we're now satisfied that when we inject power, it's not going to go somewhere unexpected. But the problem is, we don't know what this is. So we shouldn't be injecting here because we don't know what the hell we're actually injecting on. So, last piece of the puzzle, let's find schematics and find out what the hell this thing actually is and where we think we're injecting power to find out if we're expecting that to be low resistance. So reading through all this black marker stuff here, this is a DA0P5HMB. I'm going to see if I can find a schematic for that. Right, I'm coming up empty on a schematic for this particular board. That is to say, I can't find it on Badcaps. However, I did find this thread on Badcaps for a similar looking board, which I think is going to be in the same regions. Unfortunately, they don't have a schematic for this board either. But while I was reading through this thread, I skimmed through it and I did spot these pictures here. And if we have a look at this picture, we get this view, and this looks awfully familiar, this layout here. If we look at where the screw hole is, so we've got a screw hole here, we've got a little cutout of the board, we've got the regulator and the inductor and big pads and some capacitors, stuff like that. Look at the shape. Now go back to this picture. There's our screw hole, cutout, regulator, inductor, big pads for other stuff. Looks like this version of the board has a very similar layout with a very similar regulator on it. So I think we've got someone who's looking at exactly the same spot as us. So we're getting a bit of help now. So they're replacing this, which according to the folks down here is this chip. And if we go over to that data sheet, it is a 3.3 volt regulator. So this is a multi-purpose step-down regulator chip, and it also has a 3.3 volt LDO on it. So it's got two outputs. It's got it has a regulated output. So in this example, it's for 3.3 volt out. There's also a 3.3 volt LDO. And if we have a look at the description for this, the reason why it has these two outputs is, let's see, blah, 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 step-down regulator, yada, 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 minimize the size. Also provides a fixed 3.3 volt LDO with 100 milliamps current capability, which can be used to power external peripherals such as a keyboard controller in a notebook. Can switch over to the buck regulator output to save power loss. So what this chip is for is it's a 3.3 volt regulator variable, and it has a 3.3 volt LDO. So when you're in standby, you can switch to a very low power output in order to have a very high efficiency standby, because you don't really want a regulator running with a very low load on it because you're going to get poor efficiency. So basically it has a standby output and a main output. So long and the short of it is, what we're looking at here is the 3.3 volt regulator, and that is also just confirmed by other posts here as well. So this is our 3.3 volt rail. So now we know what we're looking at. At this point, I feel comfortable saying we can inject power on it and see if anything heats up. So let's get the probes ready and we'll see if we can find something that heats up on this. So as an aside, let's just see if we're lucky enough to have the same chip there as well. It'd be nice to confirm that just before I go in guns blazing, but let's see what we can do. So let's just line up here. We maintain a level of professionalism here at Adamant IT. There will be no jokes about the cum chip down in the comments below. Here at Adamant IT, we maintain a level of professionalism, so there will be no comments down below about the CUM chip. Alright, so no, it's not got the same manufacturer's code on it. However, in all probability, it is almost an identical chip in pinout and functionality. We can do a comparison with the picture that we've got, and we'll probably find, although there are a couple of subtle differences in the layout and stuff like that, the actual pinout of the chip is almost certainly going to be identical. So we can keep this in mind that A, we know what chip it is, we know what it's doing, and we know what we could replace it with if it turns out to be the cause of the problem. But with all of that said, now we know that we're looking at the 3.3 volt regulator. We know that we can bash 1 volt, add a couple of amps into that, and see if anything heats up. So let's see what happens. I'm going to take the CPU heatsink off as well, just in case it turns out that we've got a dead PCH, which is always possible. Right, I'll hook my ground probe up to the HDMI port here, just as a ground. And I've got 1 volt and 2 amps on my red probe here. And I'll bring in my P2 Pro thermal camera on my phone. And we're going to poke that regulator down there and see if anything gets hot. So I'm going to probe at the output side of it on this pad here, because that's where we're seeing 0. And also that's around where those capacitors were, which might be our issue. So here goes nothing. Is that heat on the PCH? I think that's reflections. Oh, it might be. There's a lot of reflections over there, so it's hard to tell. 2 amps might not be enough to warm that up. We're certainly not getting any heat in those capacitors there, so that's not our problem. If any of those capacitors had failed, those would be lighting up. I might just flip the board over and see if anything's lighting up on the other side. This is going to be difficult to do while I'm holding the board. I might, I tell you what, I'm just going to quickly solder a jumper wire onto that pad, just so I can turn the board around. Oh, you know what, before I do that though, I'm just going to go up to 3 amps and just see if the PCH actually lights up. Because with a shorted 3.3 volt rail, it is very, very possible that the PCH is our issue. So let's just scrub that clean. Let's go up to 3 amps and try again. I'm not seeing any heat coming through the board. All right, let's stick a jumper wire on that. Right, jumper wire connected, so now I can go hands-free. Let's turn on the power again. Oh, I'm getting a much deeper connection now. We've gone straight up to 3 amps now, where I'm not going through the probe tip, and we've actually got a solid connection into that thing. Someone down here is warming up, although we've got something over here. Let's get the macro lens down there. Is that on the other side of the board? Yeah, no doubts. Oh. Fascinating. That's an internal layer of the board. You can just see an internal trace. Yeah, I think we're internally shorted. An internal fracture, perhaps? Let's turn that off, because we're just cooking things now. Well, I think we're kill. Okay, I just stepped up to 4 amps just because we're sinking too much heat into the board. And it's very clear now that we've got a short circuit into the PCH. So, womp womp. That's us dead, folks. But just to get a happy ending out of this, let's just see if there's anything else we can do. I'm going to jump on eBay and I'm just going to search for 15s-fq motherboard. And let's just see if we can't find a replacement board for this. So top result, 80 quid, 12th gen i3. This one's got the i5 in it, £120. There we go. I mean, if we'd done board repair on this, 80 quid is what I would have charged for that. And you might say, oh, well, you know, why wouldn't you just replace the board? Well, if I were to buy this for 80 quid, I've got to charge 80 quid plus some labor to the customer. Otherwise, I don't make any money. Whereas if I'd been able to fix their board, I could have charged £80 to the customer, and that £80 would have been pure profit to me. So it is better to fix a board if you can. However, yeah, there's used boards available here. This one's an i5 11th gen, but man, that's good enough. So yeah, we've got RAM, we've got an SSD. The laptop is new enough to be worth doing this with, I think. So yeah, we're going to replace the motherboard on this. I'm not going to show you guys the process of replacing the board because it means it's going to delay this video by the delivery time. However, at this point, this is what you would do now. We've got a dead PCH, we just buy another board and we put that board in. So that's where I'm going to leave you. Bit of a disappointing result that we got this far, and we're just going to buy a new motherboard for it. This is a good illustration that sometimes board repair isn't the answer, and sometimes you can just replace the component. And you might not be able to do it for quite as good a price, but it's still a perfectly valid solution. I have had other computer shops that have called up and sort of said, oh, can I send you a board for repair and stuff like that? And I've replied to them and said, have you actually checked eBay to see if there's a replacement board? Because by the time you've paid my board repair fee, postage both ways and back, and you've tried to make a profit on the job yourself, maybe just buy a new motherboard. So yeah, that's not as a satisfying result as me fixing this and being like, look at that, we made this board work again. But hey, at least we've shown how to demonstrate that the board is actually cactus, and this laptop will survive because it's worth saving, because it's modern. So thank you very much, everyone. I'll see you next time. Bye. We maintain a level of professionalism here at Adamant IT. There will be no jokes about the cum chip down in the comments below. We maintain a level of professionalism here at Adamant IT. There will be no comments about the cum chip. I can't do it. Ooh, okay. It's not funny, but it's really funny. Oh, okay. Oh no, I can't do it. Okay. Come on. Oh. We maintain. Oh no! God, okay, I'm going to pause and walk away. I have to pause and walk away. Here at Adamant IT, we maintain a level of professionalism, so there will be no comments down below about the cum chip.